Okay, so we're going to do section 3 now. So we're going to cover probably so when you're in the exam, you're going to have two options, right? So you have section 3, you have two option topics, right? You have to choose one and only answer one, right? Don't do both because you can only get marks for one. So you have to choose one. Now, most schools will choose one topic, either object-oriented, programming paradigms, or hardware and software relationships. So whatever topic you did in class or you're more comfortable with, go in on that. So we're going to start with programming paradigms. So with programming paradigms, let's look at the first question. So just describe abstraction in the context of object-oriented programming. So so basically the idea is abstraction is almost like thinking like a black box, right? The idea is we don't care about how the internals of the system work. We just care about the inputs and outputs. So a good metaphor might be like driving a car. We don't know how a combustion engine works. We know if we turn the wheel and we push the gas pedal, we can drive the car and move, right? In the same way that in an object-oriented programming, you have an object which has methods which allow us to input and output data into this object, and we don't understand the internals of the object, but we don't care about the internals. We just expect if I do this method on the object, and I give it data, it's going to give me an output, right? And that's it. So that's abstraction. So, okay, consider the following code fragment in OOP. With reference to the current above, explain the importance of inheritance in the OOP paradigm. Okay, so basically, instantly, what is inheritance? The inheritance is the idea of having a child class and a parent class, or a subset and a superset class, whatever you want to use. And the idea is, for example, in the code, you have the generic idea of what a bird is, right? A bird has a name, a common name, a country of origin, et cetera, and then you have a specific type of bird, in the case, a water bird, which has specific qualities which aren't in a generic bird, but are specific to the water bird, which is a wader, a diver, and a water habitat, right? Attribute, right? So remember, these are the attributes, right? And something like this is what we would call a method, right? In OOP, right? So the idea is that the reason you want to do this is so instead of having to rewrite code, which is, we're programmers, we're lazy, we want to use a parent class, so we don't have to rewrite all these basic attributes, right? So it allows us to create specific instances of, like, say, a bird without having to worry about to rewrite anything. So we can just say water bird, and we know a water bird is also a bird which inherits all the classes, so, all the attributes and methods, right? So it just saves us time. Write the code to define the subclass of water bird called seabird, which has the following attributes and method. Okay, so first off, you want to define what the data types are. So this would be an integer. This would be a string, right? Int, because it's a whole number. Int, it says whole kilometers in whole meters. Those are integers. How high? Method that returns the max altitude flown by a seabird with the common name entered by the user. So you enter a string. And then you output the max altitude, which is stored there. Okay, so pretty straightforward. So we can just say, what we can maybe do is just use this as a base. So we'll just say subclass seabird is a water bird right? Um, Now, it doesn't actually say whether these are public or private. So I'm just going to say, yeah, they don't really deal with public and private stuff. So I'm just going to assume that it's all public because why not? So sometimes you have public and private, which the idea is if it's private, you can't access it directly. But in this case, they don't seem to really care whether you do that or not. So we'll just say change this to how high, and we'll just say name. Actually, we won't even say that. We'll just say how high, and we'll just say and how high, and we'll just say return. Yeah, so we'll say change this to ocean string, change this to max distance, which is an integer, change this to max altitude, which is an integer, and we'll say name equals user input, and then with a common name entered. So let's see. So a method that returns a map flown by a seabird with a common name entered by the user. Oh, so you just say, so what we can do is just say, so because there's actually a common name, so you can just literally go into here and say, I forget the syntax here, but I think you can just go common name equals user input, then return max altitude. Yeah, so I think that's the way. You might need to reference it slightly differently. Oh, so they, looking at the notes, what they do is not that. They just put common name in here, which I guess is fine. So yeah, so basically, I think that would have been fine user input, but also you can pass it in as a parameter. So usually that's either fine, either you directly get the user input or you use the input passed in as a parameter into the method. So that's fine. So yes, that's all they wanted. So that's it. That's all that. System use camera to detect which describe how software. The system uses cameras to detect whether drivers have used their mobile phone while driving. Describe how software in the system can determine whether or not the driver has used their phone. Okay, so in this course, this is an AI question. Now, AI that there's actually a very I actually can give you a very specific answer to this. And they kind of vague about how you should answer this, but I'm just going to tell you exactly. So the idea is, how would you determine whether a driver is using their phone or not? Um, uh, Basically, you would have an AI, and you would train the AI on images of people in cars who are holding their phone to their ear while in a car, right? So you train an AI model, right, on millions of images that contain people. Um, you give an AI model millions of images, right? Because a video is just thousands of images hewn together. So the idea is you train this AI model on thousands of images, right? So you have images that of a driver not holding their phone while driving, and then you have images where the driver is holding their phone while driving. And the idea is you ask the AI, do you think in this image, the driver is holding their phone or not while driving? And then the AI also first sorry, going back. Basically, the idea is you give your AI a training set of data where you give it a bunch of images that either have the driver holding the mobile phone or not holding the mobile phone, and you give it a label saying, yes, true, they are holding the mobile phone, and false, they're not holding the mobile phone. So that's what you give. That's called the training set. Then you give the AI what they call a validation set, where you give it a bunch of images, but you don't tell them the label, like whether it's true or false that there is a man or a woman or whatever, a person holding a mobile phone while driving. And then you ask it to guess, right? So it's like the AI might guess it's true. And then later on you say, okay, was that actually the true answer? And then you test your AI. Then what you do, once you've trained this model and validated it, then you release it into the real world where you can use real data from cameras to then compare real images to ask the AI, do you think this driver is holding their mobile phone or not? Right. And this model that's been trained can then give you like some sort of answer, like true or false. So um, that's all you really need to know. So the idea of an AI model is basically like a dealing with fuzzy data, right? Because vision is a really fuzzy problem because it's really hard for a normal computer program to deal with it, but an AI model is able to kind of make these decisions. So you don't need to, if you just talk about anything of like what I've said, you'll get the full marks. There's no like hard and fast rule. You can drop the word heuristic, right? Which is kind of what AIs use, which is basically like trying to figure out, you know, um, you can also mention that they use heuristics and they try to do pattern matching in the image. That would probably also give you the marks as well. So, all right, moving on. The following has been defined. Okay, logic paradigm. So the other thing is with this option topic, you will always get object-oriented and logic paradigm. So be prepared to explain the result of the following query. The basic is an elephant larger than a cat. So an elephant is larger than a horse is larger than a donkey is larger than a dog is larger than a cat. So when you do a query, basically you could do either like backward or forward chaining. So you'd say, okay, well a donkey is larger than a cat, right? So since a donkey is larger than a cat, and a horse is larger than a donkey, and a donkey is larger than a cat, right? And a horse is bigger than a donkey, and an elephant is bigger than a horse, then therefore an elephant is larger than a cat, right? That's the logic, right? You could always go the opposite way as well, which is like saying an elephant's bigger than a horse bigger than a donkey bigger than a cat, therefore elephant bigger than a cat. So you can do it either way, and you'd explain that that's how the query would be resolved, is by looking at these facts and then doing backward or forward chaining. Following rules are defined. Write a query to find animals that are both smaller than a donkey and bigger than a cat. So write a query to find out smaller than a cat. So is bigger XY, larger XY is bigger XY, larger XY, larger. But it's smaller than a donkey, and uh, so it'd be something like is bigger uh, um, uh, so let me see here. Oh, my mistake. Uh, so going backtracking, I was kind of jumping the gun. Because you only have facts and you don't have any rules, you can't evaluate this query, so it doesn't work. It doesn't return anything. With this, though, what you would say is uh, you would just basically use the is bigger rule. So you can only base a query off a rule. So basically, you would say is bigger. Um, uh, so so smaller than a donkey. So donkey. So sorry, it would be is bigger donkey X, right? Plus is bigger X cat, I think it was. Yeah. So is bigger donkey X. So the donkey would be bigger than whatever it is, but it would be bigger than a cat. So smaller than a donkey, bigger than a cat. So that's how you do it. So yes. Okay. So moving on. Using examples, explain how the use of the appropriate paradigms can improve the productivity of a programmer. Um, okay, so basically, this is a free for all. You can describe whatever. Um, I'll just pick the big ones. So I would say just uh, like you could say in a scenario where you have to create like an expert system, like for example, you're creating a system for a hospital to help diagnose patients where there's concrete facts on symptoms and you want a diagnosis or a prognosis. And so you want the doctor to enter the symptoms and then get a spout a response. Improve the productivity of the programmer. Okay, so yeah, so in that case, I'm just gonna so in that case of the hospital, it would be more cumbersome to use the object-oriented paradigm, and it's better to use the logic paradigm because if you use the logic paradigm, the problem you're solving or the system you're building matches more closely with the logic paradigm, which will make it more easy and productive for the programmer to implement, right? As opposed to other paradigms. Whereas let's say you're dealing with, like, I don't know, you're trying to create a web app with a backend database, right? Or you're creating a database, right? You would probably want to use some sort of object-oriented paradigm to treat the database as an object with certain methods that allow you to manipulate the database, right? Whereas if you're doing a database, creating a web app, it wouldn't be appropriate to use the logic paradigm. So treating a web app with an object like a database would allow you to be more productive, and it would make more sense. And most of today's functional, like programming, is object oriented in some way. So I would say something like that, and you'll get them. Okay, so that is object oriented section, and next video will be the relationships of hardware and software.